Okay, guys, welcome back to another beautiful day. It's going to be a long 2 hours today, so sit on tight. Hey, Saturday, 12:30, sorry, 12:15 to 1:30 for maths.
$50, right?
Huh?
50 ringgit per lesson, right?
It's 200 per month. We don't count it by lesson.
Oh,
Yeah,
can you message my mom about it?
sure, man. I'll message your mom later. Why your maths no good, or you think?
Yeah, I fucking failed my test, bro.
GG. Okay, quick recap over guys of everything that you're supposed to know. We're gonna be doing one more concept today, then we're gonna focus on doing some exercises today because this is gonna be a long chapter, guys. Okay. Quick recap of what we have learned so far that is going to be used today. First and foremost, last week, guys, we talked about this two formulas, right? This is basically calculating the charge in the wire, guys. The charge in the wire depends on two things. It could either be the amount of current that is supplied to the wire. It could also be dependent on the time that the current is supplied to the wire. So obviously, the first formula here, Q is equals to IT, right? Which the formula explains itself. Then the second formula, which is actually a bit weird, it's not really in your syllabus, but it's kind of like something that you should know, guys. Q equals to NE. The N is basically the amount of the number of electrons that flow in the circuit, guys. And E is basically representation of one single electron charge, guys. It is said that one single electron charge is 1.66 times 10 to the power of negative 19 coulombs, guys. So let's say, for example, 3 electrons flow in the wire and each charge is this amount, then obviously 3 times this will give you the charge that is flowing in the wire itself, guys. These two formulas are very, very, very important. For sure, you'll see it in your paper 2, one question, right? And if you're so unlucky, you might even see this in your paper 4, right? But this formula, for sure, you need to know, right? Then after that, we also talked about the difference between an ammeter and a voltmeter. Guys, I've mentioned this, it may sound dumb, right? That ammeters, for sure, everyone knows is supposed to be connected in a series, right? But I had one of my top students 2 years ago, when she was panicking in exam, she actually drew an ammeter in parallel like this. Know for a fact that this can definitely not be true. It cannot be true because ammeters, guys, have too low of a resistivity. If you connect an ammeter in parallel like this here, what happens is the current, like I said last week, right? The current will always flow in the path of least resistance, meaning to say the current will bypass the light bulb and then it will flow like this instead. So this light bulb is actually not going to turn on. Guys, you need to know this, ammeters must be connected in series, whereas voltmeters must be connected in parallel because they are the exact opposite, right? If ammeters are low resistivity, voltmeters are high resistivity, meaning to say, if let's say you are so dumb to connect a voltmeter in series like this, right? Know for a fact that because the resistance is so high, the current will be blocked here completely. If not, only very little amount of current is going to flow in this lamp. So effectively, it kind of like what's it called? Reduces the light intensity of the light bulb because the light bulb doesn't receive enough current or voltage, right? So this is something that you must know, guys. Then after that, we also talked about how the flow of current and electron goes in a circuit. Guys, know for a fact that current always flows from positive to negative, whereas electron flows in the exact opposite direction. Electron always flows from negative to positive. One way you can think about it is, let's imagine today this electron is negative, right? Then obviously this negative terminal here is going to repel it all the way until the midpoint here, where the negative electrons will be attracted to the positive terminals here. One way, but it's up to you, right? Just remember the flow. Now after that, we also introduce the concept of direct current and alternating current, right? Direct current are basically things like battery, right? They will supply current in one direction only, right? For example, the current here will only flow in one direction. But if I have alternating current here, the current will flow like this in the first cycle, then like this in the second cycle, then like this in the third cycle, fourth cycle, fifth cycle, blah, 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 and so on, right? That's why when you see the current versus time graph or voltage versus time graph, guys, you'll see that the current actually goes negative, positive, negative, positive, negative, and positive, guys. The negative and positive indicates that you move in two directions, guys, meaning to say, if you go down like this, it's considered positive. If you go up like this, it's considered negative. So this is a concept that you must know, because later on you'll use this in this whole chapter. Right. Now after that, we also talked about the difference between electromotive force and potential difference, guys. Electromotive force is basically like the source, right? I mentioned is the source of the circuit. Basically, what happens is, if today I say that I'm looking for the electromotive force in this circuit here, then obviously this is the electromotive force, because this is the source that drives the current around the circuit here. Whereas potential difference, guys, potential difference is the difference in potential between two different points. If you recall, I mentioned that this is 3, this is 1, and this is 0, right? That's why the voltmeter will read the difference in potential here. It will read the difference in potential here, and thus giving you these readings here, guys. Very, very important. You must know all of this, right? And voltmeter is obviously connected in parallel. Yeah, in parallel, because it has super high resistivity. Exactly what I mentioned just now. Then after that, this formula is going to be the most used formula in this whole electricity circuit chapter. If you don't understand this formula, you're almost as good as like you don't know this chapter already, guys. This Ohm's law, V equals to IR, guys. It's supposed to be capital I and R, right? V equals to IR basically states that, in an ohmic conductor, the resistance is going to be what's it called? Constant, right? It's supposed to be constant, meaning to say more voltage, more current, more voltage, more current, more voltage, more current, right? And since this is a graph using the gradient, guys, with this gradient here, I can tell that if I have a constant gradient, I should have a constant resistance. But for non-ohmic conductors, like your filament lamps, guys, like your filament lamps here, non-ohmic conductors, they will actually have increasing resistance. And how do I know that this is increasing resistance? You just rearrange this formula here. R is equals to V over I, right? If it's V over I, means to say the one that tilts towards the V, means to say the increase in voltage is more than the increase in current. And obviously, what's going to happen is your resistance is going to increase, right? So just in conclusion, just remember that non-ohmic conductors have increasing resistance. Ohmic conductors have constant resistance. This is actually very important, right? The very, very important formula, must know. Then after that, last week, guys, before we ended class, I skipped this part because we're supposed to learn this today. We ended the class with stating that there are 3 formulas for power, right? All these power formulas can be derived directly from the P equals to VI or V equals to IR, right? For those who have copied down the notes, it's basically just substituting this V in or this I in here, right? And if I substitute this, you'll get P equals to I square R, and you'll get P equals to V square over R here. Depending on the situation, guys, you're expected to use different power formulas. For example, if they give you voltage and current to find power, then obviously you're using this one. If you're given current and resistance to find power, then obviously you're using this one. And of course, if you're given voltage and resistance here, then obviously you're supposed to use this one here, right? This formula here is also very, 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 very important, guys, because this formula here can help you derive your what's it called, the electromotive force formula, right? Remember how to get this or not? Power is equals to energy over time, guys, and energy will equals to power times time. Then from here, your power, you just substitute this back in here. Your E is equals to VIT, right? This is one way to get the electrical energy formula, right? But if I want to find what's it called, the electromotive force, guys, I need to make V the subject. If I make V the subject, V will be equals to E over IT, right? And from here, I know that V is equals to work done over charge, guys, which is essentially what I told you guys during this chapter here, guys. This one is very, very important. The students always forget this formula because it rarely comes out in the exam. But if it does come out, guys, if it does come out, you need to know the formula, then you'll be ahead of your peers, right? Then everyone is going to be below the threshold and you'll be higher of the threshold. Then obviously you're going to score much better from there onwards. Okay? Yeah. Anyone's got any questions with anything that I've mentioned so far? Anyone didn't understand anything that we talked about last week, guys? Wait, where's the rest of my students? Who is not here yet? Jerry. I know Jerry is not here. She's having dinner. Oh, Lucas is not joining us already. Joe is not here. And okay, whatever. Okay, yeah, guys, these are the things that you need to know. Today, this is going to be the last concept that you're supposed to learn here is basically understanding how different factors of a wire could affect the resistance of a wire, guys. Now, today, if we want to understand what factors could affect the resistance of the wire, first and foremost, you need to know there are basically four things, right? The length, the area, the temperature, and also the resistivity of the wire is going to affect the resistance of the wire. Let's go through it one by one. If we look at length first, guys, imagine today I have, let's say, a wire here, right? This is one wire. And then this is another wire here, okay? Now, if you were to take a wild guess, guys, which one do you think will have a higher resistance? Do you think the shorter wire will have a longer resistance, will have a higher resistance, or do you think the longer wire will have a higher resistance? Well, let's call on to names, shall we, for this wild guess. Tavish. Oh, hi, Jerry. Welcome in. You're just in time for me to talk about the new concept. Oh, yep, you're just in time. Havish, if you were to take a wild guess, do you think the longer wire will have a higher resistance, or do you think the shorter wire will have a higher resistance? Which one is your pick? The longer one. Good, excellent. Why? Why do you think the longer wire will have a higher resistance? But more current? Not exactly. Let's imagine today, Today, if I say that there is current flowing in this wire here, right? And then there's current flowing in this wire here. Guys, today, in order to understand this concept, I want you to think back about the most simplest thing, okay? Think back about how, let's imagine today, instead of current, instead of this being current, right? Let's imagine it is water, right? And instead of this being a wire, let's imagine it's like a pipeline, guys. Today, if I have water flowing in this short pipe versus water flowing in this long pipe here, guys. Yeah, correct. You're correct. Which one do you think will be easier for the water to flow? Now, if you want to zoom in onto the concept here, we know that obviously water is made of molecules, right? And today, if there's molecules flowing against anything, obviously there's going to be some friction generated against the walls of the pipe, right? And when there are friction generated against the walls of the pipe, then the concept here is very simple. Today, if I have a very short pipe, right, then obviously there's going to be less friction. Then it's going to be easier to flow through, right? Whereas if today I have a longer pipe, obviously the water particles will have to go through more friction, and thus it is harder to flow through, right? Today, in order to understand this concept here, you just imagine this is a pipe and this is water instead of current and wires here. I know for a fact that the current will flow through here much easier compared to here, simply because there will be less friction against the walls of the pipe here, guys. So what Tavish said is absolutely correct. Today, I know for a fact that the length and resistance are actually, the length and the resistance are actually directly proportional, in a sense that if I have a longer wire here, I'll definitely have a higher resistance. And this is also one of the reasons why, guys, your parents will tell you not to, use an extension onto an extension onto an extension, something that a very typical Asian family household will do. I don't know about you guys, but I'm definitely one of those guys. I'll go to the shop, right, because I buy these 3-plug extensions. Then when I buy these 3 plugs extensions, right? Initially, obviously, because I only have 3 things, right? And suddenly I go buy another device that requires another plug in there. I realize that, oh shit, I only have 3 plugs. Oh well, it's time to buy another 3 plug extension. So the 3 plugs, right? One will have the normal plug, another one will have a normal plug, and then the last one will be another extension. Then it will extend all the way with another 3 plugs. And this whole process will keep on going until I decide that I don't need any more plugs here. This is actually a very bad habit, guys, because the longer the wire, the longer the current has to travel, right, it actually produces higher resistance. And if let's say the thing is actually faulty, right, it will actually generate heat and have a very, very, very low percentage of generating fire as well, guys. So it's actually not recommended to do an extension on an extension. So first concept here, guys, the length and resistance, they are directly proportional. Think about the water flowing in a pipe, guys. Which one is easier? Then you'll know that which one has higher resistance. From here, I know that obviously this one has a higher resistance and this one has a lower resistance. Okay, everyone get this concept so far? Assume 100% absorption rate. Let's move on to the second concept, which is the cross-sectional area of the wire here. Let's imagine today I have yet again 2 pieces of wire, right? One wire that has a cross-sectional area of this amount versus another wire with the exact same length but with a cross-sectional area of this amount here. Now, Charmaine, if you were to take a wild guess, which one do you think has a higher resistance? Which one has the higher resistance? The smaller one. Good, excellent. Why? Why do you think the smaller one has a higher resistance? You've got less space. Excellent. That is exactly the exact same concept here. Yet again, if I have a very small wire versus a very thick wire, guys, the goal here is to allow current to flow through it, right? And if I want current to flow through it, yet again, you imagine water flowing in a very small hole versus water flowing in a very big hole, right? Obviously, water will easily flow through this big hole versus comparatively to this little small hole, right? And from here, I know for a fact that because the current will flow through here easily versus the current that will flow through here much harder, I know for a fact that the resistance here is going to be less, the resistance here is going to be more. Meaning to say, guys, if I were to summarize this, resistance is actually inversely proportional to the area. The higher the area, the lower the resistance, guys. The higher the area, the lower the resistance. Whereas this one is the higher the length, the longer the length, the higher the resistance here, guys. Second concept, so far so good, guys. Everyone understand this concept so far? Yes. Let me know if you are lost, Right. Then temperature wise, guys, I mentioned temperature for last week. Scott, can you tell me how will the temperature affect the resistance or not? Will they be directly proportional or will they be inversely proportional? Scott? Directly, good. This is basically, how do we remember this? You can remember it by using the filament lamp all over again, right? Remember last week I told you that the filament light bulb, guys, is basically using this filament wire inside, right? This filament wire is actually a very dumb, not very dumb concept, it's a very old technology where it converts electrical energy into heat energy, then only it converts into light energy, Right, so what happens is, right, today when the current flows through here, because this wire here naturally has very high resistance, and when it has very high resistance, it means to say the current will be harder to flow in this wire, right? And when it's harder to flow in this wire here, what's going to happen is it will actually generate heat. This heat will be so hot that this wire will start glowing, right? And when it starts glowing, it will generate light, But because it starts glowing heat up, right? It starts heating up, the resistance and temperature are going to be like a vicious cycle, guys. The higher the resistance, the greater the temperature, the greater the temperature, the greater the resistance, and then the cycle will keep going and on and on and on and on. So this is the concept here, guys. Temperature and resistance are directly proportional. The higher temperature, naturally, the higher the resistance. And finally, the last part here is basically the resistivity of a wire here. Now, depending on the material itself, it will have its own natural resistivity. Let's say if I were to draw a V versus I graph, I know for a fact that copper wires will actually have the lowest resistivity. That is the reason why all of our electrical circuits at home and most of your electrical devices will equip copper wires, right? Because they have relatively low resistivity as a material and thus conducts electricity quite conveniently, right? Whereas if I were to compare a resistivity of a constantan wire, guys, it sounds funny, right? Constantan wire, right? Constantan material itself generally has a high resistivity, meaning to say, if I were to draw a V versus I graph, a higher gradient indicates that it will have a higher resistance, and a lower gradient will indicate that it has a lower resistance here. All right. Anyone don't know what I'm talking about so far? Anyone's got any questions so far? Good. If you have no questions, then let's go through these diagrams here, guys. Nothing else is empty, right? Yep. 8 empty boxes. Let's look through the graphs one by one, guys. It should make sense by now. The length of the wire is one of the factors that affects the resistance of the wire. I know for a fact that the higher the length, the higher resistance. So if I were to draw a resistance versus length graph, it will be directly proportional. Whereas cross-sectional area of a wire is inversely proportional, right? Meaning to say, if I were to draw a resistance versus area graph, I know for a fact that it's going to curve downwards like this, because a small area will have high resistance, whereas a big area will have low resistance here, guys. Very important. Right. And temperature-wise, it is not really directly proportional, but it is proportional, right? Of course, even at 0 degrees, right, or at 0 temperatures, there will still be natural resistance of the wire, right? That's why it won't start from 0 here, guys. It's not like you reduce the temperature to 0, then all the wires will have no resistance. It doesn't work that way. And because of that, it will have naturally some resistance, but if you increase the temperature, what's going to happen is the resistance is going to continuously increase. And finally, if I were to draw a resistivity graph of different wires with different resistance here, this is a I versus V graph, which is the opposite of what I drew just now, guys. If I have an I versus V graph, the lower the gradient, the greater the resistance, guys. So from here, you can see that obviously higher resistance will have lower gradient. And if I have low resistance, I'll have a higher gradient here. Copy everything now. Then I'll show you a very annoying formula to do a very annoying question. Aaron, copy this down. You have roughly 7 minutes to copy everything down. Start doing it now. Oh.
Sure, can you go down a bit? Sure.
Yeah.
Can you explain the ammeter part again?
Oh, uh, wait, is everyone done? Let me explain. I'm gonna copy first one. This ammeter part here, right, is basically stating that ammeters generally have very low resistivity. Okay, and because they have very low resistivity, you cannot connect it in parallel here. Why? Because current will always flow the path of least resistance. Meaning to say, if let's say I'm an idiot, right, and I decide to connect an ammeter like this, I know for a fact that my light bulb is not going to light up at all. Why? Because the current would have chosen the path of least resistivity. It could have flowed down like this, or it could have flowed towards the right? But because ammeters have such a low resistivity, all the current will choose to flow here and bypass the lamp here instead, right? So this whole thing is not even going to light up. You understand?
Okay. Thanks.
Yeah, must be connected in series, cannot be parallel. Everyone, you have 3 more minutes to copy everything now. Cepat. Okay, done, guys. Anyone not done copying this? Anyone not done copying this? Good, excellent, 100%. Let's go through one of my favorite questions here. Yeah, where is it? Where was it? Where was it now? 207. 207. Wait, can't remember which question was it really. Oh, I know where it is already. This one here. Okay, everyone. Let me tell you how the question in exams will test you on your understanding on the resistance of the length and the area, guys. First and foremost, there is actually a formula for you to calculate the resistance dependent on the factors like length and area, guys. The formula is given as R is equals to rho L over A. You might want to write this down, okay? What R is basically going to be the resistance of the wire, which is obviously measured in ohms, right? Length, this L is obviously the length, which is measured in meters, and area is obviously measured in meters square, right? This rho thing is basically the resistivity of different materials, guys. Like I mentioned just now, different materials such as copper and constantan will naturally have different resistivities, right? So this is the general formula for a resistance of a wire, but you don't have to care about the resistivity of the wire. Why? Because 100% of the questions that has tested the understanding of students here, right, they'll usually say that it is both the same wire, right? Meaning to say it's either going to be copper, or constantan, or steel, or whatever, right? So since they are both the same materials, we don't care about the resistivity since both of it is going to be the same. So how will the question ask you in your IGCSE exams? Let's say, for example, right, today they'll say that, okay, right now, right, guys, I have a wire of, let's say, for example, a certain length, right? And then they'll say that it is a certain area, okay? And then they'll say that, okay, this wire here, right, naturally will have, for ease of calculation, let's say it's 10 ohms, right? If I have another wire of the exact same resistivity, right? If I have another wire of the exact same resistivity, let's say, for example, right now, it is double the length. Let's say that. Let's say it is double the length, right? And half of the area here. They'll ask you, what resistance will the wire be? Anyone knows how to do this? Anyone learned this in school already? Anyone? Anyone wants to take a wow guess on how to do this question here? For GG. Anyone? Okay. Okay. 10, is it? Why 10? Why 10? Why 10? Why 10? Same material, Nani, but obviously it's a longer length. It's a longer length and it's half the area though. No, it's wrong. Okay, now let me tell you how to do this, guys. There's a lot of ways I've seen online that is very, very confusing. I've seen a lot of students like absolutely stare at this question like they've never seen it before. Guys, let me tell you this. This question, through my experience, I will say that at least 70% of the students don't know how to do this question. And if you are among the 30%, right, you will just push yourself right above the threshold that everyone is shit at, and it'll make achieving an A that much easier, guys. So let me tell you how to do this. You don't have to look at all the complicated formulas online or whatever your school teachers has been teaching you. You need to just compare length versus length and area versus area. First and foremost, if I look at the length versus length, guys, this is double the length, right? If I have double the length, then just now I understood that if I have increase in length, I'll have an increase in resistance, right? So based on the length itself, which doubled down, I already know that the original amount of the resistance is already doubled down, right? Double up already, right? So if let's say I ignore the area, right? I know for a fact that if let's say just looking at the length, I know that this thing will be 20 ohms already at this point, right? But obviously this is not the case because you can see that there was a change in the area, right? And if there is a change in the area, guys, always remember area and resistance, they are actually inversely proportional to each other. And if they are inversely proportional to each other, look at this area, it became half the area, right? It became divide 2, right? Area to half of the area, right? If it's divide 2, and I know for a fact that the area and resistance are inversely proportional to each other, what should I write here? Should I write divide by 2 or should I write times 2? Which one? Yes. Kunling, divide by 2 or times 2 here?
Times 2.
Times 2, excellent, good, because they are inversely proportional, meaning to say, if I double down on the area, I'll actually double up on the resistance, meaning to say, if I just look at this simple formula here, I can tell that it is going to be 40 ohms already, right? So if, in conclusion, if I double up my length and I double down on my area, my resistance will actually have quadrupled up, because here is a multiplier of 2, and here, even though it's a divide by 2, it's actually a multiplier of 2 because they are inversely proportional. Does everyone understand what I'm talking about? This is actually very, very, very important, guys. And I can tell you, they will not usually not ask such an easy question. It'll be much harder, guys. But this is the basic concept first. Anyone don't understand what I'm talking about now? Okay, everyone can understand what I'm talking about. Everyone can understand. Good. Then let me test. Oh, Jay, which part did I lose you? Which part did I lose you? No, tell me right now, because I need to test everyone right now already. Which part did I lose you? Which part do you not understand? Or were you not paying attention just now? Bloody hell. Why times 10 times? Bro, the 10 is from here, bro. The 2 is from here. Then this is times 2 because the area is inversely proportional. Just now we understood that the smaller the area, the higher the resistance, right? Right now it becomes smaller, then naturally the resistance is going to double up, right? Okay, everyone understand this part here? Let's go for a trial run for everyone, okay? Let's make it a little bit more interesting. You're expected to give me an answer, guys. You'll have like probably five minutes to attempt the question. Let's imagine today, yet again, I have a wire here, right? Let's say that this thing here is like 2L, right? And let's say this thing here is 3A, okay? And for ease of calculation, again, let's assume that this thing is 10 ohms, everyone. If I know that 2 length and 3A is 10 ohms, right? What happens if I have a wire that is like 4L and then like just A only? Everyone, tell me what's the resistance here? You have 5 minutes to attempt the question. And PM me answer. Good. Good, Kunling. Good, Junhao. Yes, Jenlin. Good, good, good. Everyone understands the concept here. Yeah, the 10B boys got it right already, guys. The rest of you guys tell me. Where did your 4 come from, bro? Jewei. Where is your 4 coming from? And why is it divided by 4? Birth. I don't know. Think about it. Think back from what we did just now. Your first step is correct. Your second step is not right already. It's 4L. This is 2L. Means to say the length how much? Multiply by how much? Bro. It's times 2, right? After, you just need to compare this, right? So, how much? See. Scott, how do you get 0.2, bro? Yes, Shermaine, you are correct. Excellent. Yes, excellent, Jerry. That is absolutely correct. McBackmo. Scott, you're the only one left. And Tavish. Where's my answer, Tavish? Yes, very good, Tavish. That is correct already. Scott, my boy, you're the only one left now. How to do this question? Tell me. How did you end up with 0.2 though? What was your calculation? Scott, if you're lost, please don't stare at the question. Please ask questions so that I know what you don't know. Nope, that's not right as well. Okay, let me tell you how to do it. Okay, wait, Scott. Just now, right? This part here. Oh God. Oh God. This part here, do you understand or not? This part here. Like the length, compare the length and the length and the area and the area. Do you understand this part now first? Yeah, right. So if I compare the length versus the length, I know for a fact that here to here is a multiply of 2 already, right? So here I multiplied it by 2 ma. Then after that, I compared here to here, it was a divide by 2, right? If it's divide by 2, by right, it should be divide 2, right? But I multiplied 2 because the resistance and area, they are inversely proportional, ma. Right, Scott? So if I look at this part here again, first and foremost, if we compare the length and the length, what's the multiple? Here, oh, times 2 already. So from here already 10 ohm times 2 already 20 already. Oh. I haven't even compared the area yet. How? Here to here is what? What's the what's the thing here? Oh, times are divided by 3. Yeah. So if here is divide 3, then here I need to multiply 3 ma, because I know for a fact that if I decrease the area, my resistance is actually going to increase, right? So from here, shouldn't the answer be 60? Namo, you understand or not? So it's 60 ohm. Okay, understand? Let's go for a tougher one, guys. Yeah, not too tough. Let's assume this is the case. Okay. Here again, this one is length, but this time this is R. Okay. For ease of calculation, let's make it 10 again. Okay. If I have another wire that is half the length, okay. I have another wire that is half the length but double the radius. Half the length but double the radius. What's the resistance going to be here? You're going to need some time for this. Think very carefully, guys. And send me answers. Everyone start doing this right now. No, that's not correct. Nope. Everyone that said 2.5, you are absolutely wrong, guys. Five is not right. 5 is not right as well. Bro, Scott, how can it be 5, bro? Just comparing the length already become 5 already. It's not going to be 10, bro. How can it be 10? The length and the area increased. How can it go back to 10? I mean, the length decreased and the area increased. Why is it not 2.5? Because this is radius, this is not area. Anyone that get an answer of 2.5, you are absolutely wrong, by the way. Oh, Jenlin, you have gotten the answer. Excellent job, Jenlin. That is absolutely correct. Easy. I'll help your 10B boys. Everyone, you have 3 more minutes to attempt it before I tell you how to do it. But I hope at least 2 more people can tell me the answer out of the 7 students I have here. Yes, good job, Kunling. What's your answer, Jerry? Don't give me this very complicated formula. Tell me the answer only. Why did you do that, Jenlin? So was it a wild guess? Bro, were you sending answers to the rest of them? GG. Alright, guys, you have 2 more minutes. I'll let you attempt it for 2 more minutes, guys. For those who didn't get it. No. Bro, wrong. Remember the answer. Yes, Junhao. That's correct. But. Jermaine, what's your answer? Or are you absolutely lost already? Two point five is wrong, so Scott. Okay, guys, let's go through this question together, guys. The first step is simple, right? It's still the same thing, if I compare the length versus the length here, this is a divide by 2, right? Now, obviously, the first step is my 10 ohm already divide by 2 already, right? Because I know for a fact that length and resistance, they are directly proportional to each other. So the shorter the length, the shorter the resistance, which makes sense, right? Just this step itself already 5 ohms already. Then after that, I need to compare here the radius versus the radius. Most of you guys went ahead and think that, oh, right here is a multiplier of 2, right? So here should be a divide by 2, ma. So everyone gave me 2.5 as the initial answer, which is absolutely wrong. Why? Because if you think back about the formula, which I hope all of you guys have already copied down by now, because I can almost guarantee none of you guys will remember it later on. It's length over area, right? These are the 2 things that affect it, right? Hey guys, the length here, okay, this is the length, but bro, this is radius, this is area. How can I justify just dividing through here? It will absolutely not make sense, right? So instead, how do I convert this into area? I know for a fact that today, if my radius doubles up, a lot of people think that, oh, if I double up my radius, this will mean to say that my area will double up as well, right? Now let me debunk this absolutely wrong idea of yours, guys. Let's just go back to basic understanding here. Let's say I have a circle here, and then I have another circle here. Let's just say this radius is 5 cm, and this radius here is 10 cm. If I were to find the area of a circle, guys, area of a circle is pi r square, right? Which in this case here will be pi 5 square, and in this case here will be pi 10 square, right? In this case here, if I were to do the calculation, this will give me 25 pi, whereas this one here will give me 100 pi. Do you guys see that by just doubling up the radius, my area actually quadruples up? It quadruples up because of this square component here, guys. I repeat, this is actually very important, guys. Don't be baited to do the wrong thing, which I actually baited everyone to do 2.5, right? Because I'm expecting it already. But from here, you should know, guys, mathematically, guys, if I double up the radius, my area quadruples up, guys. And because the area quadruples up, looking at here, a lot of you guys think that, oh, here times 2, then here divided by 2. But that formula is area, right? I'm not looking at the radius. I don't care about the radius. I, however, care about the area here, right? So from here, you should understand that when I double up my radius, let's say this is A lah, when I double up my radius, my area actually quadruples up, guys. And because here is a multiplier of 4, right? Here should not be a divide by 2. Instead, it should be a divide of 4. Meaning to say 2.5 is absolutely wrong. It should be 1.25 ohms instead. Everyone understand what I'm talking about? Anyone lost in the woods? Oh, when you say yes, you mean yes, you understand what I'm talking about, or yes, you are lost in the woods? Oh, yes, good, excellent. Okay, all right. Everyone understand, huh? Let's go for a different question then. One last question before I let you guys attempt some of the questions here. Oh, sorry. Charmaine? Okay. Say again. Which part did I lose you, Charmaine? Times 4. So if you look at this numerical representation here, when I double up the radius, mathematically my area will actually quadruple up, right? 25 times 4 is 100 lah, right? Namo, this part you understand or not? Yeah, right. So looking at this question here, you see this is R and this is double R, right? Double R means to say here is a multiplier of 2, right? What did I say just now? If your radius multiplies by 2, how will your area be affected? It will be multiplied by 4, right? Meaning to say, if let's say this was area A, then a multiplier of 4 means to say that this area will be 4A, right? Right. So if I multiply by 4, it should be divided by 4 here, which will get you 1.25. Come on. Yeah. Excellent. Good. Now, if everyone understands what I'm talking about, right? This is your last question before you go do a real IGCSE question. Okay, make it a bit harder, this one. Oh, sorry. Yeah, you can go. You can go, Jeff. Sorry. Everyone. Oh, sorry. For ease of calculation, let's say it's 10 ohms. No, let's not make it 10 ohms. 4 ohm. Everyone, do this question right now. While I go grab something to eat. Aha. What? 96, bro. How to get 96? How get 120? 4 ohm only,大佬. Hey, I think I saw a right answer just now. Wait, stop typing. What? Nope, it was wrong. No, it's not 12. How do you guys get 12? How did it end up with 12? D, bro. D for radius, is it? How about A? A for ball, is it? Then times 2 again, is it, Kunling? Is it? Wow, there's too many answers, man. Wait, I need to read one by one. Jenny, I'm really curious on how did you end up with 96 though? Like, how? In fact, everyone wants to kill myself. Oh, Kunling, I think you got the right answer. Yes, Kunling, yep, you got it right already. Congratulations, you are the first. Charmaine, you are the second. Excellent. Good. Yep, you got it right as well, Jen Lim. But I'm still curious on how do you get 96 though. Bro, 4 ohms went to 96. How? Yes, please show me. I'm really curious. Genuinely. Yes, it's diameter. Oh, man. Okay, let me check. roof. Okay, I see. Okay. Okay, Jen Lim. Let me tell you your mistake here. Okay, what you did was you took half the diameter and you divided it by 2, right? Which is obviously a quarter radius. But this quarter radius, you didn't compare it with the original diameter, right? So you're not comparing the diameter. You at this working here, you did the diameter, sorry, the radius compared with the diameter. That's why it's going to be 16. But you're supposed to compare either diameter to diameter or radius to radius. Yeah. Yeah, but now I see why already. Yes. Anyone else wants to give me the right answer, guys? Anyone? Nope, that's not correct, Scott. Yep, Junhao, you got it right already. Shut up, lah, Kending, you idiot. Yeah, I'm gonna give you guys like probably 3 more minutes to figure it out. If not, then I'll show you how to do it. But okay, not bad. Everyone can do. Not bad. I wonder how my Saturday class is gonna end up with. Anyone else or not? Nope, that's not correct, Scott. Bro, you keep doing the same mistake over and over again, bro. Okay, time's up, everyone. For those who did not get it, not so good. Right, but for those who got it, excellent job. You have grasped the concept and you are that much higher in the percentile already. Guys, yet again, we compare the length versus the length, right? If we look at here, it's a multiplier of 1.5, right? If it's a 1.5, then first things first is the 4 ohm will multiply by 1.5 already, which will land you at 6 ohms, which everyone, I think almost everyone got this answer because it's very straightforward, right? Then after that, this part here, which I assume, right, Scott, you might have thought that, oh, yet again, it's divided by 2, then you multiply by 2 here, and then you end up with 12 ohms, which surprisingly, a lot of you guys did it also initially. Which doesn't make sense, right, bro? Anyone that keeps getting 12 ohms on, wait, hello? How many times you guys want to repeat the same mistake over and over again? The diameter is not the area, right? By now, you should understand that if I have the diameter, yet again, if I were to draw a graphical representation, let's say this thing here is 10 cm, and let's say this thing here is like 5 cm diameter wise. Yeah, 5 cm. If I want to find the area in terms of diameter, area is equals to pi d over 2 square, right? And then again, this one here will be pi d over 2 square, right? From here, it's essentially going to be pi 10 over 2, which is going to be 5, 5 square, right? It's going to be 5 square. And this one here will be like pi, oh god, 2.5 square. If you press this into your calculator, this will obviously give you 25 pi, right? And this one here is supposed to give you, I think, how much? 6.25, is it? Oh, shit. Yeah, 6.25. 6.25 pi. Yeah. 6.25 pi will be an effective area reduction of divide by 4, guys. Meaning to say, the area is the only thing that is constant. The radius and the diameter, if let's say if the radius divides by 2, your area actually divides by 4. And if it's a diameter divided by 2, your area divides by 4 as well, right? From here, okay, before I move on, anyone don't understand this part or not? Anyone don't understand this part or not? The diameter and the radius are effectively working the same way. Double up the diameter, you quadruple up the area, you double up the radius, you quadruple up the what? You don't understand this part, really? Which part am I losing you, bro? Bro, here you can see that the diameter divided by 2, right? Can you see? Here, mathematically, I can't explain this. You can see that the area divides by 4, right? Yes. Yes. So in other words, if my diameter goes by half, then my area goes by a quarter, right? A quarter, right? Can I say this? Yes. Yes. So it works the exact same way like the radius, right? If today my radius goes half, right, my area would go a quarter also, right? Do you understand or not? What do you mean kinda? This is mathematics, bro. Which bro, just press into your calculator. Just press in your calculator 25 divided by 4. Will it end up with 6.25 or not? If yes, then it proves that when I divide my radius or diameter by 2, my area will actually go down by a factor of 4. 明白冇會? No. Right. So, mathematically, yet again, if my diameter divides by 2, assuming that this is going to be area, this will be a quarter of the area, right? Which yet again shows me that it's a divide by 4, right? And since area and resistance is inversely proportional, instead of multiplying by 2, I should multiply it by 4, which will end up with 24 ohms, right? Namo. Understand or not? Yes. For radius also it's the same. Even, okay, if I change the situation up a little bit, if let's say this is D and this is double D, right? Like double the diameter, right? Then what's going to happen is, right, if let's say this is area, this will be 4A already because of the square component in your formula here. If let's say if I were to make it even more complex, right? Let's say, for example, if let's say this is D and this is like 3D, right? If it is 3D, my area, if let's say this is area here, this one will be 9A already because of the square component here yet again. So in conclusion, you need to understand that why it goes to quadruple is because of the square component. If I double, I'll square it and it will go quadruple. If I triple, I'll square it and it goes 9 times. If let's say it's 4, if let's say it goes from D to 4D, right, from D to 4D, it will actually be 16. You understand or not? Wait, understand or not? Understand. Okay. Anyone don't understand what I'm talking about this part here? Anyone don't know what I'm talking about or not this part here? Good, excellent, 100% absorption rate. Everyone look at this question and tell me what is the answer. You have 4 minutes to do this.
Right.
Oh, Jerry, excellent. Pavish, good. Junhao, wrong. Lim, wrong. Kunling, wrong. No one has this page. Yes, Kunling, correct. Oh, good, Shemate. Excellent, good job. Yes, Lim, that's correct. Wow, Kunling, not bad, huh? Doing very fast on these kind of questions. Who was the first one to get it correct, though? Oh, Jerry and Pavish. Guess. I hope you didn't guess the correct answer because when the question change a little bit, you'll get it wrong. Yes, Junhao, that's correct already. Scott, my boy, what's the answer? Nope, that's wrong. Scott, you want to try again? I'll give you another 2 minutes to attempt it. Nope, that's wrong as well. Are you guessing all the alphabets at this point? And yet you didn't guess the right one. It's donkey. Why? 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 For those who have guessed your answer, right, please pay attention. So if we look at this question here, it says that a cylinder of conducting putty has a length L, this is the first information, and diameter D. The resistance is R. The putty is now molded into a cylinder of double the diameter that has the same volume. This is the keyword. It has double the diameter, but it has the same volume. Thinking logically, right, since it has the same volume, how will the length be affected? Will the length increase or decrease? How will the length be affected? Will the length increase or decrease, guys? Right. Stay the same? Is it? Is it gonna stay the same? I hope you're trolling me, Kunling, because volume definitely doesn't work that way. It definitely decreases lah, right? Why? Because if you look at it logically, let's do some mathematics here, guys. Volume of a cylinder is pi r square h, right? Right. This in this scenario here, it will be like volume is equals to pi d over 2 square multiplied by L lah, right? This is the first information you have. Then guys, they say that it is remolded into double the diameter. So because it has the same volume, I can still use V here lah, right? So V is equals to pi 2D over 2 square, right? And then there is one missing component here. I don't know what's the length here, but through mathematics, right? If I were to expand this bracket, I'll get V is equals to pi D square over 4L, right? So from here, if I were to say that since they are supposed to be the same, the left side should be equals to the right side, right? So this will be V pi, since there's the 2 and 2 cut off already, it will be D square already, right? Then this is my L, I don't know how long it is, but if I look at it mathematically, in order for this thing to be like this thing, this length must be at least a quarter of it, right? Then only this part will be equals to this part, right? Did I lose anyone so far? Okay, everyone understands this part, Very important, guys. It's very important. Okay, this part you understand, right? This part you understand, right? It's literally just substituting everything in and expanding the bracket only lah. Yeah. Then this part here, I don't know what's the new length, but I know that logically speaking, if I need to mold it into a larger diameter, then the length must shrink, right? But shrink by how much, I don't know. It could be a multiple of, it could be a factor of 2, it could be a factor of 3, it could be a factor of 4, I don't know, right? I don't know. But if I were to expand the bracket, if I expand this bracket here, it will be pi, the 2 and 2 is going to cut mathematics, right? Then it's D squared already, right? Then this is just the only empty component, Then you ask yourself, how much must the length decrease by in order for this thing to be the same as this thing? Because they said that it should be the same volume, right? So if you want, you could go try and error also, right? If you go try and error, it looks something like this, like, oh, I don't know how much is the length. Maybe it divide by 2, Maybe it divide by 2. Then I see here, this and this also not the same. Then obviously it's not right. Then, oh, maybe the length had a fact divided by 3. Then you see, this thing also not the same. Then logically speaking, the only way for this thing to become this thing here is to have a factor of 4 division, right? The length. Meaning to say the new putty, the new putty with double the diameter will only be a quarter of the length only. It will only be a quarter of the length because all the volume is used to increase the diameter. You understand what I'm talking about? Oh, you understand what I'm talking about? If you don't understand, you better say, Okay, I repeat again. So this part is for certain already. This is like, you understand this part, right? This part is just literally expanding the bracket here only. You understand, right? Okay. Then after that, this is the only part. Mathematically, I know that volume is equal to pi r square o times h, right? But since right now I don't know how much is the length, I can only substitute this information in, right? This information I substituted into the formula, which in this scenario here will be 2d over 2, right? Because I want to make it into radius, right? And then square, then the 2 and 2 are going to cut, right? So it would end up with d square, right? Right, you understand this part, Okay, then after that, the final part here is just to make this formula the same as this formula because the volume is the same. This volume and this volume should be the same. So I ask myself, how much should the length decrease by in order to be the same volume? If I'm like super mega retarded, right? I just put L here, right? It doesn't make sense, right? If I put L here, then this thing is clearly not the same as this thing, right? It's the same reason why like A is not for a ball, right? So I know for a fact that, okay, it's not going to be length. Then I start dividing it, maybe it decreased by a factor of 2. If I decrease it by a factor of 2, by right, when I expand this bracket, it should be the same as this thing here, which looking at the scenario here, obviously is not the case, because this will be pi d square L over 2, this will be pi d square L over 4. So no, for sure, no, it's not going to be 2, it's not going to be 3 also, it must be 4, right? It must be 4 in order for this thing here to become this thing here. Do you understand? So from here, this is the only thing I need to do only. I need to know that the length divided by a factor of 4. Once I know that the length divided by a factor of 4, right, I can draw that for visual representation, then it's easier, right? Then it's like, okay, this thing is 2D, then this thing is like a quarter of the length. Then from here, I can start comparing the stuff already, here to here, divide by 4. Okay, so for sure it's a factor of 4 already, right? It's for sure a factor of 4 already. And here to here, the diameter double up. And when the diameter double up, what happens to the area? What happens to the area, Janim? When my diameter double up, my area will what? Double up also, or what? Sorry, Janim. Increase by 4. Yeah, it will increase by a multiple of 4. So if let's say here was area, because the diameter double up, here will be an area of like quadruple the area, right? Because I just showed you mathematically, right? That means to say here to here, since it's a multiple of 4, yet again here will divide by 4 again. So that is why your factor is going to be 16. Everyone understand what I'm talking about or not? Anyone don't understand all this? Anyone wants me to repeat specific parts or not the whole thing? Anyone wants me to repeat this? Okay, everyone understand this, Okay, let me find one more question just in case. Wait, here. Electricity circuits. One final question before I let you guys do your exercises. Tell me an answer here. This question. It's not. It's nothing related to the top. These are all the information you need. Obviously, not that simple. Yeah. But it won't be that direct, bro. This is not a maths class. No, that's wrong, Kun Ling. You're giving me the exact same answer as Jen Lim. Hey, if it was that simple, I wouldn't ask you guys to do it, right? For those who want to answer me 3, it's not correct, guys. Wow, you're thinking out of the box, Kun Ling. Out of the syllabus also. No, these are all the information you need. How can it be 9, bro? Think about it. Think, bro. How do you end up with 2, Jen Lim? That's not correct. Good, Junhao, correct. You are absolutely right. Now the 10B boys will know already. Good, Jen Lim. That's right. Yes, Kun Ling. Excellent. Yes, Jen Lim. That is correct. Yes, Jermaine, that's correct. Excellent. The rest of you guys, are you lost in the woods? Okay, guys, for those who are lost, right? Just think about it this way. If today I have a resistance area of 12 ohms versus a resistance area of 4 ohms, which one will have a larger cross-sectional area? Will it be the 12 ohm one that has a larger cross-sectional area? Or will it be the 4 ohm one that has a larger cross-sectional area? Who hasn't given me an answer yet? Abish, which one do you think has a larger cross-sectional area? The 4 ohm one or the 12 ohm one? Yeah, for sure this one will have a larger cross-sectional area, right? And this one should have a smaller cross-sectional area one. So if let's say this is A, then this must be triple the area, right? And in other words, the ratio should be 1 to 3, right? That's why it's only 1 mark. Bruce. You understand our word, boys and girls, especially those who didn't give me an answer, man. Mình bạc mùa cũng thôi. Anyone don't understand this part? Yeah, it will be the same thing. Okay. Now, if everyone understands this part already, for the rest of the 15 minutes, please attempt all the questions here. Everything of this ABC here. Everything until you see this page here. Then we'll discuss the answers by next week. Then we can move on to the next chapter. Start doing exercises now, guys. Last 15 minutes. Next week is also another fun and exciting chapter. Okay, Aaron, you can start doing everything here already. I print some stuff. Do until where? Do until you finish the chapter. The next chapter is going to start off like this. So until you see this, you finish doing it. Yeah. Hmm.